Okay, all right, ladies and gentlemen, let's continue where we got cut off. Yeah, hopefully you come back in. Now, we come to see the logistic regression, and we know that there are times when independent variable are not categorical, are not continuous. Yeah, it's categorical. So we have to handle the data in a different way to be able to analyze it in a proper way. And there are times when the dependent variable are binary or binomial outcome. I mean, when, for example, when you apply for a loan, they may say yes or may say no, right? That's a binary logistic regression. Or sometimes you may you may have multinomial data, which means you have more than two options, but they are not continuous. For example, your grade, okay, letter grade. In US, we have letter grade A, B, C, D. That's categorical and that's ordinal. A is better than B, B is better than C, and so forth. So there are these an example that is multinomial, not just binomial. Binomial means you have two outcomes, two results. Multinomial means you have multiple outcomes. And ordinal means they are in order. They are in order. So we have multinomial and ordinal logistic regression as well. Okay, so your project 3 is you need to work on a project, okay, in two parts. The first part, you choose example where you can apply the multiple regression, where dependent variable is continuous variable. And you have multiple independent variable to predict that continuous dependent variable. That's multiple regression. That's the first part you should show in your first in your project 3. The first part. The second part of your project 3, you should work on the logistic regression. At least you should find a dependent variable that is a binary, okay? Binary, that's binomial dependent variable, and you have multiple independent variable to predict it. Or if you could also find a multinomial logistic data set for you to study the application of multinomial and ordinal logistic regression, that will be fantastic. Okay, so you need to work on this too, and if you use real statistic, you will be able to what? Use a real stat to address this to do all the calculations for you. All right, let me see. Yeah, okay. To do all the calculations for you. Let me show. Yeah. Once you install the real statistic, then you can go to regression and multinomial linear regression, where you input your data range and declare a number of independent variables, and make sure you have headings or not, and so forth, plug in alpha and so forth. You should be able to do the logistic regression for multinomial, or binomial is a special case of multinomial, so that's why it shows multinomial. So Okay, if it can handle multinomial, then it can definitely handle binomial. Okay, so you have you have all these. All right, and logistic regression. Okay, here are some, and you go to this website, real statistic for examples of logistic regression. You will see the theoretical background for logistic regression, and you will also see an example for it. Okay, is actually the odds ratio. Odds ratio. The odds ratio make it continuous and only on the positive part of the real line. Now, if we take a log, then we turn that odds ratio to the entire real line, including positive and negative. So in that case, we can use convert through that through that link. Logit we call it logit function, where is log of the odds ratio. We are able to turn that into an exponential function and use the concept of regression to model it. Okay, so this is the theoretical background here, and let me see. This is just a repeating the odds ratio, and then you can come back and then look at an example of, for example, 760 people who received doses of radiation between 0 to 1,000 rem was made the following recent nuclear following a recent nuclear accident, and then 302 died as shown in the table. And now each row in the table represents a midpoint of interval of 100 grams. Okay, so you have an odds ratio, how many rem and how many survived, how many died. Okay, so this is a simple logistic regression. Okay, only one independent variable, but I hope you can find an example of multiple independent variables for that logistic regression. Because, for example, apply for loan. You apply for a loan, and the result may be approval or rejection, right? That's a binary outcome. But in your applying for a loan, you are supposed to fill out in a form your income, your age, how many members in your household, what your bank saving, right? How much money you have right now in your bank account, your education level, your gender, your how many languages you speak, so on and so forth. You are required to fill in many blank. Those are variables, but not all the variables are influential to your loan outcome, which is approved or not or rejected. But this is a good example for what logistic regression. Eventually, through proper use of the model, you will come up with the best fit model, which means you can predict that outcome with the proper variables. Okay, on the one hand to describe your data, on the other hand to predict. In case in the future, once you have the model, then you can say, okay, given this person has how much income and so forth, you plug in that information, the outcome that he will be accepted or approved or rejected will be approved or rejected. That's a model you can use to make the prediction. Okay, let me. Okay, and then logistic regression. In addition to use R, I also allow you to use. I mean, in addition to use Excel, I also allow you to use R. And here is an example with tutorial that you can see how to use R for logistic regression. Okay. There are some theoretical background as well, but here is step-by-step instruction how to build a logistic regression. Suppose this is the model, so then you read the data into the model, and then you do the analysis, use GLM function in Excel, and so forth. You will come up with the analysis. This is your data set and analysis. Okay, how to predict and so forth. So, and you have the full code for this analysis. Okay, and conclusion. Okay. All right, so this is how you can use R to do it, and I also give you files for doing the analysis. Let me see analysis in the 4th class. Okay, here I lecture on logistic regression on 4.4, where you can refer to for multiple or logistic regression, multiple regression. Okay, I call it stepwise. Why is it stepwise? And what you need to look at the BIC, Bayesian information criterion, Schwartz information criterion, and so forth. Okay, normally BIC is enough. The smaller BIC it is, the better. Okay, this is a criteria similar to adjusted R-square or AIC, Akaike information criterion. Those criteria, I click on the link, you will see that is a criteria that you look at to see, to avoid overfitting, but ensuring that the model, the independent variables in the model are influential. Okay, so and then you can refer to it for stepwise regression in R. The stepwise regression, as I had mentioned previously, is the regression that you drop. For example, if you do the backward regression, you first include all the models, all the independent variables in the model, and then drop one out at a time. Okay, and you drop one out at a time, and then until you keep the one that with the minimum AIC in the model, and then you have the, for example, you have all 3 independent variables in the model. Okay, you drop one out, and so you have the 3 different combination of the two variables, and then you choose the one that the combination of the 2 independent variables that give you the minimum AIC as previously mentioned in the slide as a criteria. Then you keep that model, and then what? Then you drop one of the 2 out separately to see if that can continue to reduce the AIC or not. Okay. Otherwise, if not, then you keep the model that give you the combination of two independent variables out of the three, which will give you the minimum AIC. Okay, this is a backward stepwise regression model. Forward stepwise regression model means you start from 1. Okay, backward start with all the variables, and forward start with one variable. You try variables in the one at a time, x1, x2, x3 separately. Then you keep the one that has the largest AIC. Then you add another variable along with it. For example, you keep x1 in the first place. Then the second step, you add x2 to x1, okay? And then you keep x1 and x3, all right? Then you compare the AIC of these two combinations and then you keep the one that gives you the minimum AIC. But overall, you need to keep the one that has the minimum AIC, so in order to finalize the best model. Okay, so I have also give you some references in our code here for your reference. There is an example here. It uses cancer data, but of course not directly related to finance. If you can find one that has to do finance, that's a perfect. All right. But make sure, for example, if you click on this IBM cancer data that was used for SAS in illustrating the logistic regression model, you need to be careful which one to you use as your dependent variable, because some students may make a mistake of using you need to use the one that has a binary outcome to be in the to be the dependent variable. Okay, make sure you know which one is your dependent variable. Okay. Oh, this one is marketing. This one is marketing data. There's another one that I use cancer data. Okay. Anyway, where is that? Oh, not this one. Right here. Stepwise. Stepwise data set. Oh, this one. This one is the cancer data. Okay, that when you use, you need to. Of course, I suggest that you find one that's financial data set. Okay, for this type of analysis. Let me show you the. Okay. Of course, this is how to use SAS for logistic regression analysis. But the data set here is a cancer data set. Okay. Now it shows you AIC and so forth. That criteria I mentioned for your determining which one is the best fit model. And here you have these this data set, and you can download at the bottom. I believe here. Here. No, this is just an example. Not that you are to use it. Okay. And where is the data set? Mm. Oh, here. Okay, this is a data set, and so your dependent variable in terms of using this example as for logistic regression need to be remiss. Yes or no, yes or no. Okay, so the others are influential predictors. Okay, I mean candidates for being incorporated into the model to predict for your prediction. Okay, for your prediction. Whether it you see this is binary outcome, right? 1100 and so forth. So the others could be your what these from the just the first 1 2 3 4 5 6 7, just first 7 columns, and the first one is your dependent variable, binary dependent variable that qualifies it to be used in multiple logistic regression. Okay, so yeah, and so you can see, have a look at how they do the analysis and so forth to learn from it. Although this example is more about health science, not finance. But in principle, the application is the rationale is the same. Okay, all right. Let me see. Yeah, we have 40 minutes plus 60, 62 plus 6. Yeah, we almost did about 2 hours recording up to this point. Let me recap a little bit. I'm going to end this session within 5 minutes. Then I will record the last section on hypothesis testing to make it 3 hours lecture for the class we missed today. Okay. Okay. So now the point is for project 3. Okay, project 3, you need to you can use either Excel or R for that project. Okay, and when you work on that project, you should, if you use Excel, then you should download the real statistic, because you have the logistic regression, you have multinomial logistic regression, and you have the multiple regression, okay, to generate those functions for you. But remember, the criteria you use for those regression is that you look at the p-value in determining which variables are to be kicked out and which one are to be kept. You look at the p-value along with the adjusted R-squares. Okay, if p-value is too high, you kick that one out and check whether adjusted R-square increase or not. Eventually, you find a combination that yields the largest adjusted R-square. That means it's the number of parameters included is the optimum, and the R-square it explained away is the most. Okay, that's the first that's consideration. And then in terms of multiple regression, you need to find a data set with the binary or binomial or multinomial outcomes, which are categorical. In other words, you will find a dependent categorical variable with binomial outcome or multinomial outcome. Okay, multinomial means you have multiple options, but all categorical, like your letter grade A, B, C, D, which is also ordinal as well. And you will find a multiple independent variable to influence that letter grade, right? The time you spend for studying, your GRE scores, and the time you spend, you watch TV, okay, and so forth. You should also become the influential factors affecting your letter grade. Okay, makes sense. So then you make analysis based on, if you use R, then you probably can look at the AIC, BIC, because R provide those output for you, and you can refer to the PowerPoint in a more detailed way. You will see how to use stepwise regression in determine a best model. Okay, step by step. Okay, I think this will be good enough for me to conclude the lecture here. I have already, with these two videos, I already cover 2 hours, and we will use the remaining time for the third section. Okay, okay, all right. Well, I'll stop here, and I'll see you next time. Meanwhile, feel free to send me email. I will help you out with any questions you might have. Okay, have a very good day. See you next time. Bye.